Hey everybody, Mr. Gajewski here, and today we're going to talk about factoring quadratic trinomials when a, that is the leading coefficient, is not equal to 1. So let's take a look at a few examples here. So my first example is 5x squared plus 11x plus 2. Now we could go ahead and use a guess and check method. Look at all the different factors of 5, all the different factors of 2, compare what's going to give me a sum of 11x in the middle there. But using a process like that gets a little tedious and time consuming. There's another method we can use. And what we're going to do in this method is we are going to turn this trinomial into a 4-term polynomial and then use the factoring by grouping method. So let's try this first example. The first thing I'm going to do is take the first term, 5x squared, and the last term, 2. And I'm going to go ahead and multiply those together. So 5 times 2 is going to give me 10. Then I'm going to factor 10 out, and I'm going to be looking for factors of 10 whose sum is equal to the middle term, in this case 11x. Well, what are factors of 10 with a sum of 11? How about 10 and 1? Now I can take 10 and 1 and I can rewrite this trinomial as a 4-term polynomial. So that's going to look like 5x squared plus 10x plus 1x, or x, plus 2. Now we have 4 terms. Let's go ahead and let's factor this out. Well, I'm looking at the first 2 terms. What can I factor out of 5x squared and 10x? Well, the greatest common factor of 5 and 10 is 5. The greatest common factor of x squared and x is x. When I factor out a 5x, what is left over? Well, 5x squared divided by 5x is going to give me x. 10x divided by 5x is 2. So a positive 2 or plus 2. Next, I'm going to look at x plus 2. What's the greatest common factor of x and 2? Well, it doesn't look like anything, but if you remember, any number or any term does have a factor of 1. I can always divide it by 1. So let's factor out a positive 1. What's left over? Well, nothing's going to change. We have x plus 2. So now I can factor by taking out a common binomial. What's that common binomial? X plus 2. When I do that, what's left over? Well, I have a 5x and a plus 1. So what is that going to look like? Well, that'll give me 5x plus 1 times x plus 2. And if I want to be sure, I can do a check here. So let's do that. Let's do 5x times x, which is 5x squared. 5x times 2 gives me 10x. 1 times x gives me x. And 1 times 2 gives me 2. Go ahead and add the like terms. So this works. This is my original equation. So my final answer, my factored form, is 5x plus 1 x plus 2. Go ahead and circle it. That's our final answer. Let's go ahead and try another example. This time the value of c is negative, in this case minus 5. So I'm going to do the same thing. I'm going to start by taking 4 and negative 5, and that's going to give me negative 20. Now I'm going to think of factors of negative 20 whose sum is equal to 8. Well, how about positive 10 and negative 2? 10 times negative 2 gives me negative 20. 10 plus a negative 2, or 10 minus 2, gives me a positive 8. So we'll go ahead and we'll write those down. 10 and negative 2. Let's rewrite our trinomial as a 4-term polynomial. 4a squared plus 10a minus 2a minus 5. Well, go ahead and group. What can I factor out of 4a squared and 10a? Well, I can factor out a 2a. And what's left over when I factor out a 2a? Well, 2a plus 5. What can I factor out of a negative 2a and minus 5a? Or excuse me, minus 5? Well, again, they don't have a common factor, so I can factor out a 1. When I go ahead and factor out a 1, that'll still give me negative 2a and a minus 5. So let's go ahead and let's factor out a negative 1. When I factor out a negative 1, the negative 2a becomes positive 2a, and the negative 5 becomes plus 5. Let's factor out a common binomial, 2a plus 5. And what do we have left over on the inside? 2a minus 1. That is my final answer. If you're not sure, go ahead and do a check. And last example we're going to do together here is, what do I do when the value of a is negative? In this case, negative 2x squared plus 5x plus 12. Well, we can't have or don't want a negative a term. So what we can do to make that positive is we'll just factor out a negative 1. When I do that, that's going to change the sign of every single term. So the negative 2x squared becomes positive 2x squared. Then we get a minus 5x minus 12. Let's do what we did with the first two. Let's go ahead and let's multiply 2 times negative 12 to get negative 24. And now I need factors of negative 24 whose sum is equal to negative 5. Well, this is a negative number I'm trying to have my sum as, so I'm going to have the bigger of the two factors be negative. The smaller will be positive. And in this case, how about negative 8 and positive 3? Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. So we can go ahead and rewrite our trinomial as a 4-term polynomial, except we're going to have that negative 1 just hanging out in the front. So that's going to give us negative 1 in parentheses 2x squared minus 8x plus 3x minus 12. Let's go ahead and group. So I'll turn my parentheses into brackets and then group with parentheses. Remember, the negative 1's still going to hang out front. And what am I going to get? Well, what can I factor out of 2x squared and 8x? Well, I can factor out a 2x. That'll leave me with x minus 4. And what can I factor out of 3x minus 12? Well, I can factor out a 3. And that will leave over an x minus 4. Factor out a common binomial. Again, rewrite -1. And when I factor out that common binomial of x minus 4, what do I have left over? 2x plus 3 times x minus 4. And again, if you want to do a check, go ahead and distribute all of the terms. You will get our original answer, or our original trinomial, of negative 2x squared plus 5x plus 12. Don't forget to circle your final answer. Thank you for watching, and if you have any questions, let me know. I'll see you next time.